not on the computer here. Alright. So, mean value theorem and Rolle's theorem. How do they relate? How do they connect? What ways are we going to use them to be successful? The history of Rolle's theorem is based on this imaginating idea that you have, and I know there's like a little block at the top of your page. Just go down to the history part. I think my slides are a little out of order today. So imagine that you have 2 points on the x-axis. And now imagine all of the differentiable functions which could go through those 2 points. Since our functions are differentiable, they are continuous, and their graphs cannot have any holes or breaks. So that's what you have to remember. When you are given the statement that a function is differentiable, you need to imagine in your mind that that function is continuous with no curves, no holes, no breaks. There are no sharp corners. There are no vertical tangents. These graphs of all of these functions have one property in common. That property they have in common is that the derivative will equal 0 at the extrema. The one property they have in common is that these points will have tangent lines at f prime of c equal to 0. And that is where Rolle's theorem came from. It came from the idea of these closed, continuous, differentiable functions in which their a and b are at the same height and their derivative is equal to 0. So the conclusion of Rolle's theorem states that there must be at least one c in the open interval AB where f prime of c is equal to 0. You need to be writing down what is in yellow. So we have, show that the example x cubed minus 6x squared plus 9x minus 2 satisfies the hypothesis of Rolle's theorem on that interval. And find the value of c which says that is true. So once again, I'm going to do this problem with you. So what do we need for Rolle's theorem? In order to prove Rolle's theorem, you must state f is continuous and list it as a closed interval or list it as an open interval, but you must list it for each part. So we have to say that f is continuous on its closed interval. We have to say it is differentiable on the open interval. And we know that it is continuous and differentiable because f of x is a polynomial and all polynomials are continuous. So that's just sort of like a side tidbit piece of information. For part 3, you have to show f of 0, in this case negative 2. You have to show f of 3, 27 and 27 is 54. 54 minus 54 is 0. And we get negative 2. So we have f of a equals f of b, which equals negative 2. So it meets condition 3 of Rolle's theorem. So therefore, by Rolle's theorem, I am guaranteed a f prime c equal to 0 between 0 and 3. Rolle's theorem guarantees this. Rolle's theorem guarantees that value. If it asks me to find the value, then I have to set my derivative equal to 0. And solve for c. Okay? And then solve for c. So we get c equals 1 and c equals 3. Those are also considered the critical points, as well as the values guaranteed by Rolle's theorem. Okay? And then we have the mean value theorem. The mean value theorem, and that's where I said we have to now actually kind of go back up to the top. I just flip-flopped my order. Is a geometric comparison of MVT. MVT is essentially a tilted version of Rolle's, in which both theorems conclude that there is a number c such that the slope of the tangent to f at x equals c is the same as the slope of the line connecting the two ends of the graphs. So the difference is that in Rolle's theorem, the height of f of a and f of b have to be the same, and in MVT, the two ends of the graph do not have to be the same. So looking at these connecting points, up at the top of your page on that line graph, you could kind of draw in this continuation of that. The idea is that this slope of the secant line, so this would go at the top on that little graph area, where you place 2 points anywhere on a coordinate plane that have the same y value, and that would show you Rolle's. If you make them have a different y value, that shows you the mean value theorem. So if you make a f of a and b f of b have the same y value, then you can see the connection between Rolle's and MVT. I can go back and kind of almost do that with you. So again, you want to make them have the same y value. And if you draw in that curve, the conclusion is still the same. The only difference is now that your f prime c is horizontal. Where in the mean value theorem, it can be tilted. in Rolle's theorem, it has to be horizontal. So therefore, the C value that makes that true can only happen at the extrema that also makes that true. Whereas in the mean value theorem, it can be tilted and slightly curved. So again, that's the connection between the two, where this can be tilted. In Rolle's theorem, it is horizontal. Okay, so we can pick up example 2 at the top of the next page. And it says, for f of x equals 5x squared minus 4x plus 3 on the interval 1, 3, calculate f of b minus f of a and find the value of c such that f prime c equals m. So, this is a quadratic. Quadratics are continuous. Quadratics are also differentiable. So 1 f of x is continuous. 2 f of x is differentiable. If when you get a justifying question on the AP exam and you don't justify this, you don't get your points. These two statements are imperatively so. Part 3, we want to find f of b minus f of a. So we're going to find f of 3 minus f of 1 all over 3 minus 1. So f of 3 in this case is 5 times 3 squared minus 4 times 3 plus 3 minus 5 times 1 squared minus 4 times 1 plus 3 all over 2. So 45 minus 5 is 40. 40 minus 12 is 28. 28 plus 4 is 32. 32 divided by 2 is 16. Is everybody okay with that so far? The next part then is to find your derivative. So in order to find our derivative, we have to find f prime of c, which is 10c minus 4. And then we want to find the value of c in which the derivative is equal to the slope. So we want to know, when does 10c minus 4 equal 16? And the answer is 2. So what that means is, if I found f prime of 2, my value of f prime of 2 is the same value as the slope of the secant. So this represents the slope of the tangent, or an instantaneous velocity. This represents the average velocity, or the slope of the secant. So at the value of 2 on that curve, the slope of the secant equals the slope of the tangent, or the instantaneous velocity is equal to the average velocity. It's the time at which you are driving your average speed. Does that make sense in terms of applications and problems? Find the equation of the tangent line to the graph f of x equals 2x plus sine x plus 1 on the interval 0 to pi at the point which is the solution to the mean value theorem. Okay, 2x, continuous. Sine x, continuous. 1, continuous. So function composition says the sum of continuous functions is a continuous function. So f of x is continuous. Part 2, can you derive that function? Part 3, find the slope of the secant. So that's f of pi minus f of 0 over pi minus 0. So that's 2 pi plus sine pi plus 1 minus, well, 2 times 0 is 0, minus sine 0 minus 1 all over pi. Your 1's cancel. You get 2 pi. What is the sine of pi? Good. And what is the sine of 0? So we get 2 pi over pi. What's 2 pi divided by pi? 2. Thank you. So the slope of the secant from 0 to pi is 2. F prime of c is equal to 2 plus derivative of sine, which is cosine. So f prime of c is equal to 2 plus cosine x. Wow, how nice is this? Because you set the derivative equal to the secant. So you get 2 plus cosine x equals 2. Subtract 2 to both sides to solve for x. And you get cosine of x equals 0. So when does the cosine of x equal 0 for what x values? From 0 to pi, it only equals 0 once. Pi over 2, perfect. So it says find the equation of the tangent line. So I'm not done. What does that pi over 2 represent? It represents the value at which this occurs, right? So x equals pi over 2 is kind of like my f prime of pi over 2. So the equation of the tangent line would occur at pi over 2. So I know my slope, I know my x, I need my y value. So pi over 2 isn't your slope, pi over 2 is the x coordinate for which the slope is 2. So 2 pi over 2 becomes pi. Sine of pi halves is 1. So 1 plus 1 is 2. So you get 2 plus pi for your y value. So again, it's always important to read the directions. Oftentimes we fall into a habit of, oh, I found pi halves. That's the mean value theorem. I'm done. Well, okay, you did apply the mean value theorem and you did get the correct answer, but the question itself was asking for the equation of the tangent line on that interval for the mean value theorem. We also fall into habits that everything applies to everything. The mean value theorem does not always work. The mean value theorem does not always work. So here we have an example. We have 3x, absolute value of x minus 3. What do you know about an absolute value? Go ahead, guys, all three at once. Yeah, it's got a sharp corner, right? It's not differentiable. What you have to be really cautious of is, does that sharp corner fall in my interval? Because you can have a graph. So like if we graph this function, just so you can kind of get an idea. Oh, my window's bad. If you graph this from 2 to 5, oh, I'm so silly. Do you actually end up seeing that sharp corner in that interval? Can we see it? Okay, it is. It's super hard to tell, but the change in the graph is right there at 3. So, sometimes you get tricked into thinking graphs are smooth and continuous, and they're not, even when you look at them on a calculator. We kind of understand this idea, though, right here, that curve is shifted to the right 3 units. So it says, explain precisely why we cannot apply the mean value theorem. And you would say, at 3, the graph has a corner. And why does that matter? For differentiability purposes. Therefore, it is not differentiable from 2 to 5. So I put the function in y1, right? On your graphing calculators, you could actually try to prove that. You could go to math and go to option 8. And we could put our function in option 8 and try to find it at 3. Oh, of course, I must have hit my stuff wrong, but it gave me 3. No. Good, calculator. It's not differentiable. I told you our calculator's having trouble showing that cornery edge. Part B, where do you know that one's not differentiable? That's easy. -2. So that would give you a vertical tangent. Therefore, it is not in our domain. If it's not in my domain, what is this graph not that fails the mean value theorem? Exactly. Okay, and then the last one. X equals 2/3. That's our graph that has a what type shape? What type shape is on a 2/3 graph? Kind of looks like the bird. A cusp. Where's my cusp going to occur? When you take your derivative, you get 2/3 x to the negative 1/3, which means my x variable drops down to my denominator. So if I have an x variable in my denominator, what happens, or where can that not exist? It cannot exist when that would equal 0 or at 0. So h prime of x is not differentiable at x equals 0. Therefore, once again, MVT does not apply. Okay? So for your homework, I want you to go backwards in our packets a little bit. We skipped over a page that looked like this. And had Rolle's theorem on it. So what I want you to do is the odds on that packet. It's on the rules. Actually, I know I just said odds. Do it evens because you're going to do evens in the textbook, so we're going to keep everything even. So do the evens in that. So that's 4. That's 14. In your book, let's do 2 to 8. So 2 to 8, 12, and then 202. Sorry, same page as the other night. And all of this, I'll have you upload the other night's homework and then the worksheet in this. So evens on Rolle's theorem. Page 202, 2 to 8, evens, number 12. And then, there's not a lot of good questions in our book on MVT. Kind of is disappointing. Number 40. No, I don't want to give you an odd. How about 36 and 38. So 2 to 8, 12, 36, 38. And then the Rolle's theorem handout. Now, for the Rolle's theorem handout, guys, if you don't want to use Rolle's theorem and you want to use mean value theorem, that's totally fine. Remember, Rolle's theorem is like the sibling of MVT. So if you like MVT more, the only thing you're doing with Rolle's theorem on MVT is saying f prime of c equals 0. So you could do the f of b minus f of a, MVT can apply 4 rules, which is why we do them together.
So we're just turning in the 1 to 21 odds even last night and the 2 to 8 even this 12,
Yes.
36, not
Yep.
not the stuff from Wednesday, right? We went over that.
Yeah, because we already went over that. So what I want you turning in for Monday is the page 202. The numbers, you guys did 1 to 21, right?
1 to 21 odds.
Yep. And then turn in numbers 2 to 8 even, 12, 36, 38, and evens on Rolle's theorem. And like I said, a majority of that should kind of be done because that was our homework from the other night. And this is exactly what I'm going to go type and put on Fusion in case you need that too.